Students, this is lesson preview notes, lesson 3.5. The dates have changed on this. And as discussed in class, you should be watching this on October the 23rd or the 24th prior to class on the 27th and the 28th. Don't forget to get the location, the date and time, as well as a parent, guardian, or teacher sign-off. It says here, that finger track and read. In triangle ABC, AB is a mid-segment. Find the value of x. Start with a thing equation before the algebra. So in this case, if AB is a mid-segment, we know that A is a midpoint and B is a midpoint, and this is a mid-segment. I'd like you to do your best to pause the video, try this on your own, and restart it when you're finished. Okay, welcome back. You should have done a thing equation beforehand, and your thing equation looks like this. The mid-segment is half of the side that it's facing. So we know that AB is 1/2 of XZ. AB is 1/2, so here's AB, and it is 1/2 of X to Z. You can use this now to circle plug chug. So AB is 3x minus 1 equals 1/2 of 34. From here, you should have just solved for x, and that's all I requested you to do at this point. So 1/2 of 34, so I have 3x minus 1 equals 17. Add 1 both sides. We have 3x equals 18. Therefore, x is 6. Now, just to double check it, we plug in 6 here. 3 times 6 is 18 minus 1. That means it's 17, which is 1/2 of 34. All right, for the past 4 classes, we've been talking about relationships within a single triangle. Triangle guts, types of triangles, isosceles triangles, scalenes, acute, right obtuse, etc. Now we're going to talk about relationships between triangles. Here's some vocabulary you need for today. And the vocabulary, we're going to be talking about geometry. Motion is slide, flip, turn. Translation, reflection, rotation. Congruent, CPCTC. Pre-image, image, corresponding, and whole and part. By the time you're done with this video, you should be able to give a quick definition of each of those. So I want you to imagine that you had a cardboard triangle here on the left. This is called a pre-image. And if you simply slide it to the right, so we're going to slide, so write the word slide to the right. If you were to slide this to the right, so pretend you had a traced triangle and you just physically slide it to the right. Obviously the triangle, is exactly the same. Looks like it. The triangle before you move it's called the image. After you move it, before you move it's called the pre-image. After you move it is called the image. That is a slide. That slide has another name. In math we call that translation. Now, I'd like you to trace this on the left, please. That's your pre-image. Now, imagine if that was a cardboard triangle, you just picked it up and flipped it. Flipped it like you flip it over a border or a line. We're going to flip it. So just write the word flip over a line. That's your pre-image on the left. Pre-image on the left. If you flip it, you're going to end up with a triangle that looks like a mirrored image. That's your image on the right. That motion of flipping has another name besides flipping, and that is called reflection. Looks like that space bled over to the other side, so that was called, again, reflection. If you're flipping over a border. Last motion. Now trace this triangle. Now imagine if I had a turning pivot here. That's why there's a circle here. Imagine if you were to pivot around that pivot there. So you're going around a pivot, or a turn as we call that. That's your pre-image on the left and your image on the right. That's called a rotation. So there's three motions in geometry: slide, flip, and turn, better known as translation, reflection, rotation. Translation, reflection, rotation. Now, I'd like you to take this R and just write a translation of the R, reflection of the R, and a rotation of the R. It'll take you about 30 seconds. Okay, translation just means you slide, so the R should look exactly the same. A reflection would be as if you have a mirrored image. So it's going to go a mirrored image. Rotation, it honestly doesn't matter how far you rotate. So I could rotate it 90 degrees. I could rotate it 180 degrees, etc. But you can see that that is a rotation. I'd like you to pause this video, and on this page, I'd like you to determine the motions being seen here. Translation, reflection, rotation. Restart the video when you're done. Okay, welcome back. Hopefully you actually stopped the video and did this on your own and then have come back. This first one, this is a reflection. Number 2 is a rotation. Number 3 is a reflection. Number 4 is just a slide, so that's called a translation. Number 5 is a reflection. Number 6 is another slide, so that's a translation. Okay, now that we have triangle motions down, now we're going to talk about triangle congruency. So first off, I'd like you to take a look at the triangle on the left and the triangle on the right here. And I'd like you to tell me, what is the motion of triangle BCD to triangle RST? What is the motion between these triangles? Translation, reflection, or rotation? I'd like you to fill that spot in right there. Okay, you should have said rotation. I want to show you why. Slide would be exactly the same. A reflection would be a mirrored image. But if you look carefully, angle D, the 3 swipe, corresponds to T. And to get D in the same position as T, you'd be rotating counterclockwise. If I took that and rotate that counterclockwise, I would end up with the same image. So when you move triangles, you're going to end up with congruent triangles. Now, as we move this, you have to very carefully align the sides. Ready? Let me show you what I mean. In this triangle, angle B, circle angle B here. Notice that's a 1 sweep, corresponds to the angle R, which is a 1 sweep. And side B to C, notice I go from B to C. I go from single sweep to double sweep, corresponds to side. I have to go single to double as well. Single sweep, double sweep. That's R to S. The order of the letters is important. I'd like you to take a minute and just fill out the other 4 positions, pause the video, fill them out, restart the video. Okay, welcome back. Let's see what you did here. Angle C, that's a double sweep, corresponds to angle S. And C to D goes from double to triple. So double to triple would be S to T. The last one, angle D, is the triple sweep. It goes with the other triple sweep, which was T. And D to B is from the triple to single. Its corresponding side is triple to single here, which would be T to R. The order of the letters is important because these are what are called corresponding parts. They're called corresponding parts of a triangle. When triangles are congruent, corresponding means in the same position. So notice when the triangles are congruent, you're going to have 6 pairs of items. 6 pairs of items that are congruent. So you take a shot at this one. It says you must correspond the congruent vertices. What is the motion of the triangle from the left to the right? What is the motion of this triangle? Then I'd like you to complete this sentence. Triangle MLW is congruent to which triangle? Do that on your own. I'll give you about 30 seconds. Okay, if you look carefully, 1, it's not a slide where you'd end up with the exact same triangle. And you know it's not a mirrored image because if I put it like this, I'd end up with something that looks like that. It's neither a slide nor a flip, so we can see here very carefully that W rotates in the same position as N. So this is a rotation. Now watch the order of the letters. M, L, W. M, single. L, double. W, triple. I'm going single, double, triple. I must go the same order on the right-hand side. Single, double, triple. And that would be single would be triangle L, in this case. Double would be vertex M, and then triple would be, whoops, let's get the color straight here, N. So once again, trace it. M, L, W, single, double, triple, corresponds to L, M, N, single, double, triple. You must correspond those vertices. Ready? Again, take a shot at this one. Same process. Name the motion. Correspond the vertices. Pause the video, do this, and then come back. Alrighty, welcome back. Now you should notice that this is not a rotation. This is a reflection. It's a mirrored image. So you should have reflection. Now let's look here. We have R, which is single, Q, which is double, and then E, which is triple. So we're going in this order: single, double, triple. We must follow that exact same order on the right-hand side. Single, double, triple. So your matching here is going to be triangle R, Q, P. Single, double, triple. So right up here, what we learned is, notice I have congruent triangles. And if I have congruent triangles, I have congruent parts. In other words, if I tell you these triangles are equal, then individually angle E and P are equal. You know, sides EQ and QP are equal. Those are the parts of the triangles. So that gets us to this definition right here. Really touchy screen, hang on. If the whole triangles are equal, the parts are equal. And that is the definition of the acronym CPC-TC. It's a really fancy acronym to something super simple, so don't let the long acronym freak you out. It simply means corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Say this out loud with me. Corresponding parts of congruent triangles are congruent. That's CPC-TC. Long acronym for something super simple. Think of it this way. If your whole hands are equal, if you have two congruent hands, they're exactly the same shape except they're mirrors of each other, right and left. If the whole is equal, then the individual parts are equal. The fingers are equal. If the whole is equal, the parts are equal. Now we're going to talk about where do you get congruency in triangles. I'm going to be using a term called freebies. This is not a technical term. Freebies, in my definition, means things that are true always, even when they're not in provided information. So they're true because of the diagram, even if I don't list it as true in like a word problem. If you see this scenario, it's automatically true. There's three common freebies. The first, and I've warned you about this several times, the most common are vertical angles. This pen is a mind of its own. And it seems this side of the bed. Tend to cooperate. Vertical angles. There we go. Those are always congruent. You see them, you mark them, go. The other side is a reflexive side. All right, the second. This is a new one you haven't seen before. Let's say I take a triangle here and I slice it down the middle with a straight line. Now you see, technically you see three triangles. There's a larger one, and then there's a triangle here on the left, and a triangle here on the right. That left and right triangle, the yellow and the orange, they share this side down the middle. We call that a reflexive side. It's like an apartment wall shared between two apartments. That is congruent to itself. So when you see a reflexive side, you actually mark it with a hatch mark. And when you start marking angles congruent, I need you to get starting to put in the habit. If I have a pair of angles congruent, you put 1A for a pair of congruent angles. This would be considered an S for a pair of congruent sides. A third freebie is something called reflexive angles. If I have two triangles, see this red triangle and this blue triangle. Do you see how these triangles overlap? And they exactly share this angle here, the pink one. All right, now they do not exactly share that blue angle. They don't share those blue angles. So that blue angle is not reflexive, but this angle right here is shared by both triangles. So I would mark it congruent, and I would put an A for one pair of angles. So these are freebies. If you see these in diagrams, you should mark them congruent. So let me show you some freebies below. In this triangle here, we have this AD, that's a reflexive side. Trace it, hatch it, put an S for a pair of sides. In this diagram, do you see this one triangle here? Trace it. You see the larger overlapping triangle? Trace it. And right here in these two triangles, this angle right here, I'll call it the toe angle, that is shared by both triangles. So that's a reflexive angle. Congruent to both, so I write A for angle. In this diagram, we have a pair of bow ties. So mark it and put A for a pair of angles. Get in the habit, whenever you have a congruent pair of either sides or angles, put S for sides, A for angles, one letter for each pair. So I'd like you to pause this video, finish this page, on your own, and restart the video. All right, students, did you actually pause the video and do this on your own? I certainly hope so, because that's a good learning practice. If you're just copying, that's not learning. So if you actually did this on your own, hopefully you did this in pencil, you should be grabbing your red pen right now so you can correct. So we're trying to take a look at the motion from left to right. And we can see, one, it's not a slide. The slide would give you the exact same triangle. It's not a slide. Two, it's not a mirrored image. So imagine if there was a mirror. It's not a mirrored image. Therefore, it must be a rotation, which is, if you look carefully, what happened is that this triple here rotated counterclockwise up. So the triples correspond, and this rotated here, and then the doubles rotated this way. So watch carefully. K, S, I. Triangle KSI. So look what we're doing. KSI. Trace it with me. Do it again. KSI. That single, double, triple is correspond to triangle T, U, S. Single, double, triple. Single, double, triple. This is rotation. You should have marked the freebies below. This one right here, there is a pair of reflexive sides. Mark it, hatch it, S for a pair of sides. Here, you have a pair of vertical angles. Mark it, hatch it, A for angles. Here, another pair of reflexive sides. Sweep, hatch, S for one pair of congruent sides. Here, we had two overlapping triangles. They exactly share the vertex H. Therefore, that's a reflexive angle, A for angles.